Hello and welcome to P Academy. So in this video, you're going to be looking at the concept of resistor. So you're going to be looking at everything that has to do with resistor in terms of its definition, its symbols, the types, the units, resistor color coding, resistor in series, in parallel, just everything that you need to know about resistor, especially at the basic or at the fundamental level. So if that is all and more that you want to know about it, so do make sure you watch the video to the end. And before we get started, if you are new to this channel or you are here to subscribe, please kindly take out time to click on that subscribe button. You find it just below the video or on that square red box, you see subscribe written on it. So just click on it and then you'll be able to subscribe to the channel. Alright, so kindly just take 2 seconds to do that. So to click on that subscribe button. Alright, so thank you very much if you have just done that. Alright, so now let's get started. Let's talk about resistor. So what is a resistor? Exactly. So if you are to define a resistor, basically you'll find different definitions of what resistor is, but you have to take note of some of the key things and try to understand what actually a resistor is. So we can say that a resistor is a two-terminal circuit element in which the voltage drop across it is proportional to the current through it. So let's just analyze it. So like you can see on the screen now, I just gave 2 different definitions of what a resistor is. So you can, if you go online, you see as many as possible, but let's just work with these 2. So again, it says a resistor is a two-terminal device. So now let me first of all draw the symbol for it. So if you look at a resistor now, you can see it's a two-terminal device. So this is what it means with a two-terminal device. So these are some keywords that you can use when defining what a resistor is. It's a two-terminal circuit element, or you can just call it a two-terminal passive element. So that's another keyword, passive. When you have, remember we have passive and active components. So you can just say it's a two-terminal passive. So but if you don't want to put it, you can just still leave, but make sure that two-terminal is also there, because if you look at it, it's a two-terminal element in which the voltage drop across it is proportional to the current through it. Now what this definition is saying is, if you are to put it out mathematically, it says the voltage drop is proportional to the current. So that means that the voltage V is proportional to the current, which is I. Remember, that's the symbol for current. And then if you are to simplify this now, you are going to be having, that means our V is equals to Ri, where this R, which is the resistance, is the constant of proportionality. Yeah, we good. So if we should make R the subject formula, we can just see that R is equals to V over I. So that is the explanation on one of the definition of what a resistor is. So again, this symbol that I have here, you can start to draw a resistor like this, exactly, or you can also have it like this. So whichever one you decide to use, you are still correct. So you can use any of these 2 symbols to represent what to represent a resistor. So now let's analyze the second definition that we have. It says a resistor is an electrical component that limits or regulates the flow of electric current in an electric circuit. So once, if you are to explain that, it says it's an electric component that limits or regulates exactly the flow of electric current in an electric circuit. Now let me use this diagram here to explain what this is saying. If you look at what we have here, this one at the top, if you look at it closely, resistor is written on it. Resistance is written on it. So you can see that the resistance is what is regulating the current. The current is this guy that is trying to pass through this this channel. So like, as you can see here, so why the voltage is the one that is just based on the analysis, is just pushing the current, but the resistance is one that is regulating it. Okay, that the amount of current that want to pass through that particular conductor or that particular channel or passage. So you can see it. So that this picture is one of those pictures that really explain what a resistor is, or a resistance anyway. Okay, so now let's go back to it says a resistor is an electrical component that limits, you can see, or regulate the flow of electric current in an electric circuit. Are we good? All right, so we've looked at the definition and then in terms of the symbol. So now let's quickly look at the types of resistor that we have. So if we are to talk about the types of resistor, so types of resistor, basically there are 2 types. We have, number 1, we have the fixed resistor, and number 2, we have the variable resistor. So the variable resistor. So from the word fixed resistor, it says that so these are resistors whose values are just fixed. So if you have a resistor that the resistor is let's say 5 ohms, exactly, so that's the unit of resistor. Also ohms is measured in ohms. So if you have a resistor that is 5 ohms, just take it as it is 5 ohms, exactly. So there might just be a little difference of maybe 5 point something, but just take that as 5. The value is fixed. But once we have a variable resistors, that means the value changes over time, exactly. That means it says that for this case, different values can be obtained as the shaft of the resistor turns. So the values can change. It's just take it like the word fixed resistor and then variable resistor. So if you have to put that in the symbol, you can just like the way you draw your regular resistor like this. So you can, this is that for fixed. But once it is variable, so once it's a variable, you're going to have this arrow just crossing over it like this. That's indicating that it is a variable resistor. Are we good? All right. So another thing I also want to mention is that you see that I'm using the word resistor and resistance interchangeably. So now let's quickly talk about the difference between when you see a resistor and then when you hear the word resistance. Exactly. So in case the two is like you're confused about what actually the difference between when somebody say a resistor and a resistance. So in explaining it, let's look at these two analysis or two definitions. Now we've defined what a resistor is earlier. So but let's look, it says a resistor is an electrical component. So that's just the key thing you need to take note when you measure a resistor. It's just the component, it's the physical one that you can see. Exactly, that you can see, you can touch, you can pick, you can know. You might be in the lab and it's okay, go and bring a resistor. It's the physical component. Now, but when we talk about resistance, it says it's a property of the material which opposes the flow of electricity through it. So the property of that resistor itself is what we refer to as what, as resistance. Exactly. So like the analysis I gave, maybe you're in the lab and you're doing a particular and you are asked to go and get a resistor. Exactly. So you can say it's a resistor, but you won't be saying, you won't be told that go and bring or go and get a resistance. Exactly. So it's a physical component itself. The physical component itself is the resistor. Why the property of that resistor itself is what we refer to as the resistance. So I hope that makes sense. And like I already mentioned earlier, the unit of so the unit of resistor is actually in ohms. So it's in ohms. So this is the symbol, something like this. So all right, so before we round up on this particular part of this video, so another thing I want to talk about is the relationship between so that's the relationship. So that's the relationship between the length, the cross-sectional area, and the resistance of the material. So if you're asked that, what's the relationship between this thing? So it's actually a formula that relates every of these things together. But let's first of all write out some of this, or maybe we should first of all write out the formulas. So the formula that relates all of this together is, so resistivity is equals to RA over L, where this symbol is what we call resistivity. So resistivity, and then the R is for resistance. The A is the cross-sectional area. So I can just write that as area. So that's CSA that's cross-sectional area. And then the L is the length. So it's the length of the conductor or the wire. Okay, so this is the relationship between the length, the cross-sectional area, and the resistance of a material. So depending on how you want to apply this formula now, then you can decide to make any of them the subject formula. Exactly. So you can decide to, maybe if you want to use, if you are to use the resistance as the subject formula, so you're going to be having something like this over A. So exactly. So you can just mix it anyway depending on the question. So that's what I want to cover in this video. In the next part of this video, still on resistor, we are going to be looking at resistor color coding. So how do you determine the value of a particular resistor based on the color coding on that particular resistor? So if you find value in this particular video, please give it a thumbs up. And then if you have any question or any doubts, do let me know in the comment section below. And with that, I'll see you all in the next video. Thank you.